Uniformation kicked the Resin 3D printer door wide open with the GK2 back in 2024. It brought genuinely user-facing features like a no-mess build plate, a latch-in resin vat, and an actively heated chamber, and it did it at a price that still made sense for homemakers. At the time, it was arguably the best printer of its generation, and it put Uniformation firmly on the makerspace map. What came next was less straightforward. The GK3 launch was messy. Instead of a clear successor, we got the GK3 Ultra plus three nearly identical variants: the GK3T, the GK3B, and the GK3 Pro. On paper, the differences were subtle enough to be confusing, and early coverage didn't really help clarify which one would actually made sense to buy. After the dust settled, I picked a model that looked like the best overall balance of price and performance. This is the GK3T, and I've been running it pretty much non-stop. Over the course of just 2 weeks, I printed more than 150 individual parts across 40 separate print jobs, totaling nearly 100,000 printed layers. I burned through over 6 liters of resin and logged close to 300 hours of active print time. This wasn't like testing, this was production style use, so today I'm taking a deep look at the GK3T, what actually separates it from the rest of the GK3 lineup, how it performed under sustained use, the problems I ran into along the way, and the results it ultimately delivered. Welcome to the Elevated Makerspace. With any tool, especially a 3D printer, the first thing I care about is deployment. How quickly can you go from opening the box to actually doing useful work? With the GK3T, that process was mostly straightforward. Opening the box, you start with the usual documentation, accessories, and power cable up on top. The printer itself is well packed, reinforced edges, thick open cell foam on all sides, and the entire machine was wrapped in a plastic bag. That bag actually made it easy for one person to lift the printer straight out of the box without wrestling with it. Once the bag is off and the lid is open, there's another large foam insert inside. That's where you'll find the carbon filter and the build plate. From there, assembly is minimal. Slide the magnetically mounted carbon filter into place, screw in the Wi-Fi antenna, connect the power cable, and power the machine on using the button under the tilting front panel. Following the setup guide, the next step is raising the Z-axis so you can access the resin vat. The vat is held in place with 2 latches so it comes out easily. I removed it and peeled off the blue protective film from both sides of the FEP release film. The LCD itself ships with a screen protector already applied. After that, the printer walks you through an exposure test. Then it's time to install the build plate and verify leveling. The GK3 ships pre-leveled from the factory, but resin printers can take a few hits during shipping. In my case, the plate wasn't perfectly parallel to the screen when it arrived. One corner was noticeably loose. That actually made this a good opportunity to walk you through the GK3 leveling process, because this plate works a little differently than most. The GK3 build plate is a 2-piece design. The top half mounts to the Z-arm. The bottom half is the aluminum build surface that presses against the screen. Between those 2 halves are 4 springs controlled by 2 sets of screws. The 4 outer hex screws compress the springs and hold the 2 halves together. The 4 inner screws act as locking stops that define the final spacing between the 2 halves. This is where many people get tripped up. So you start by loosening the 4 outer screws, turning them counterclockwise about 3 or 4 turns. You're not removing them, just relieving some spring tension. Next, turn the 4 inner screws clockwise. That feels backwards at first, but it's critical. Turning them clockwise actually lowers the screws, which gives the bottom plate freedom to move during leveling. With the screws set correctly, lower the Z-axis to the 0 position using the paper strip method. Because the inner screws are lowered, the springs can compress naturally and the plate can settle evenly against the screen. The paper strip should feel equally snug on all corners, which tells you the plate is truly parallel. Now comes the second place people often mess up. Tighten the outer screws clockwise only until they just make contact with the top plate. Do not torque them down. If you over tighten these screws, you compress the springs and actually lift the plate off the screen, undoing the leveling you just did. These screws are only meant to capture the plate's current position, not change it. Once the outer screws are just touching, turn the inner screws counterclockwise to raise them back up until they contact the top plate. This locks the spacing between the two halves and prevents the springs from compressing further during printing. With that done, the build plate is fully secured, and in my case, it ended up perfectly level. From there, the rest of the setup was uneventful. I connected the GK3T to Wi-Fi and checked for firmware updates. The system reported that none were available, which turned out to be not true. I'll come back to that later. I also installed the Uniformation app and paired the printer. Finally, it was time to load resin. The GK3 ships with an empty resin cartridge already installed, which becomes useful later. For the first print, I removed it and slid in a fresh cartridge of standard HD gray resin. With the auto feed system enabled, the printer was ready to start its first job. Now, before getting into the print process and output quality, it helps to ground everything with the hardware itself, so let's quickly walk through the specs and core features of the Uniformation GK3T. Physically, the printer measures 392 millimeters wide, 332 millimeters deep, and 520 millimeters tall. It uses an up and over lid design, which extends the total height to 724 millimeters, or about 28.5 inches when fully open. The build plate design is carried over from the GK2, and it's still one of the better implementations in its class. You get an XY build area of 211 by 118 millimeters with a maximum Z height of 240 millimeters. The plate sits deeper than the resin vat, so the top surface stays clean during printing, and there's an integrated drip edge that helps keep resin where it belongs. It also uses a contoured mounting handle for easy one-hand installation and locks in place with a tension latch. No thumb screws, no guesswork. The Z-axis is built around a single linear rail paired with a T10 trapezoidal lead screw. This is where things get interesting because Uniformation makes it a point highlighting the GK3B's use of a ball screw instead of traditional lead screws. On paper, that sounds like a meaningful upgrade. Ball screws are common in CNC machines and industrial equipment because they're very efficient and move smoothly under heavy loads. In a consumer MSLA resin printer, though, that advantage doesn't really translate into better prints. A trapezoidal lead screw is simple, rugged, and largely self-locking. It tends to be effectively self-lubricating when it's paired with polymer bronze nuts, and it requires very little ongoing maintenance. It tolerates dust and resin vapors better, doesn't demand frequent cleaning or re-greasing, and once it's properly aligned, it just works. At the slow Z-axis speeds used in resin printing, a lead screw already provides more than enough precision. Ball screws, on the other hand, rely on tiny recirculating steel balls to reduce friction. That means tighter tolerances, more moving parts, and more opportunities for wear or contamination over time. They need to stay clean and properly lubricated, and if debris becomes an issue, performance can actually degrade significantly. In real-world MSLA use, there's no meaningful improvement in layer consistency or dimensional accuracy because the printer simply isn't moving fast or under enough load to benefit from a ball screw design. So while a ball screw sounds more industrial, in practice it adds cost and complexity without delivering noticeable print quality advantage for most home users. In this class of printer, a well-implemented lead screw is already doing the job just fine. Now, moving on to the resin vat, it's cheap, utilitarian, and honestly exactly how a resin vat should be. It's simple plastic design with an 800 milliliter capacity, an FEP release film, plus a fill sensor that works with the automatic resin feed system. There's a slot to stand and allow the build plate to drain after completing a print. The pour spout is a little awkwardly placed, but for me that wasn't a big deal. The worst part of resin printing has always been handling resin and the cleanup, and Uniformation's approach here minimizes both. Replacement vats cost about $50, so I picked up 2 extras and dedicated 1 vat per resin type. Each vat includes a lid and they stack cleanly for storage, and I keep them in a cubby right next to my Formlabs Form 4 vats. The vat clips into place and locks with sliding latches, no thumb screws or fiddling. Under the vat is the same 10-inch 16K LCD panel used in most printers in this generation, with a native resolution of 15120 by 6230 pixels. That works out to an XY resolution of roughly 14 by 19 microns. Smaller pixels are nice, but it's important to understand the trade-off. While pixel size shrinks, the control electronics for each pixel doesn't shrink proportionally. That lowers the fill factor, meaning less of each pixel actually passes light. To compensate, manufacturers have to push more UV intensity. More UV means more heat, and over time, more wear on both the light source and the LCD. The good news is that replacing the screen here is as simple as it gets. Remove 4 screws, lift the assembly, disconnect the ribbon cable, and you're done. Replacement panels run about $150. The assembly does feel a bit prototype-like, with the control PCB just taped to the frame, but functionally, I guess it works. Below the LCD is a Fresnel lens focusing the 405 nanometer UV light from a large COB light source. This is also where the chamber heater lives. Just like the GK2, the GK3T heats the resin from below. While that might sound hard on the screen, in practice, it's not really. The heater only brings the resin up to about 25 to 30 degrees Celsius, which is barely warm in electronics terms. And because the LCD isn't running a constant backlight like TVs and monitors, wear is driven far more by cumulative UV exposure than by this low-level heating. Uniformation rates the light output at 4.6 to 5.2 milliwatts per square centimeter. My measurements averaged about 4.4 milliwatts per square centimeter across the screen, with a low of 3.98 and a high of 4.79. That works out to roughly 83% uniformity from dimmest to brightest points. Looking at it another way, the coefficient of variation came out at about 5.4%, meaning most of the screen is fairly consistent, even though one side is clearly dimmer. Printers using the same 16K panel with a distributed LED array typically land closer to 3 to 4% variation and higher worst case uniformity. Multiple LEDs naturally smooth things out. In practice, this setup still prints well, but exposure needs to be tuned to the dimmest areas of the screen. One important note here: on my unit, the stock PET screen protector was cutting UV output by over 25%. Removing it brought output back to where it should be. Now, I don't recommend running without a protector, but I do recommend replacing this one with something better. I usually cut a piece of FEP or PFA to size and tape it down. Wrapping up the hardware, the GK3T uses a 5-inch capacitive touchscreen mounted on a 90-degree rotating panel. Hidden behind that panel are the power button and a USB Type-A port. You also get a 720p 2-megapixel camera for live monitoring and time-lapse recording, along with the integrated carbon filter and automatic resin filling systems. It's also worth calling out what GK3 doesn't include, because those emissions shape how it behaves in real use. There's no force sensor or debris detection, so the printer won't automatically stop if cured resin is left on the screen. There's no automatic build plate leveling and no power loss resume. Everything here is intentionally straightforward: manual leveling, traditional lift and peel motion, and a restart if something goes wrong. That keeps the hardware simple and reliable, but it does mean the printer relies more on proper setup and user awareness than some recent, more automated designs. Now, before getting into print quality, it's worth laying out the test parameters and workloads, because context matters here. For all my testing, I use Chitubox Basic as the slicer. It includes a solid, well-tuned profile for the GK3T, and in practice, it worked exactly as expected. Uniformation does offer their own branded slicer, which adds tighter integration with features like the resin autofill and some convenience UI elements. But in terms of core slicing behavior, exposure control, lift parameters, and support generation, Chitubox handled everything I needed. I didn't run into any compatibility issues or missing features that forced a switch to Uniformation Slicer. So all of the results you'll see here were produced using Chitubox. Over the 2 weeks I had the Uniformation GK3 on the bench, it ran nearly full time. This wasn't a handful of stage prints for B-roll, even though these models do look great on camera. The printer was used as a production tool, running day and night. By the end of the test period, I logged over 325 hours of powered operation, with more than 285 of those hours spent actively printing. That works out to roughly 88% uptime, excluding routine maintenance, plate removals, and the necessary pauses to free parts and swap resins. In that time, I ran through over 6 liters of resin. That includes 2 Uniformation resins, along with materials from Sunlu, Soraya Tech, and Haygears. I wasn't limiting this to a single use case either. I printed a wide range of models, from practical functional parts to smaller 32mm tabletop miniatures to quarter scale multi-part statues and assemblies. Individual print jobs ranged anywhere from an hour to up to 20 hours per plate. In total, the printer ran continually for nearly 12 days, printing almost 100,000 layers, producing 150 individual parts across 35 models on nearly 40 build plates. Now, I normally skip calibration prints altogether. Most of the time, I'll load the manufacturer's resin profile, slice a real model, and just send it. In this case, because I manually leveled the build plate, I did start with the level check print included on the USB drive. Once I selected the file, the printer copied it from the flash drive onto the internal memory, which is always nice. It removes one more potential failure during long prints. After that, the automatic resin feed kicked in. One thing to be aware of here is that the system doesn't just add the resin needed for the print, it fills the vat all the way up to the sensor and keeps it topped off throughout the entire job. You don't have to use the autofill system at all, though. You can still pour resin manually if you prefer. I personally didn't have any issues with the auto feed system during testing, but I have seen reports from other users who have, and in almost every case, it comes down to the vat not being fully seated or the level sensor not making proper contact. So if the auto feed starts acting strange, the first thing to check is that the vat is clipped in squarely and fully locked, and that the sensor area is clean. Reseating the vat or wiping the sensor usually resolves it. From there, the printer heated the resin as needed and started printing. About an hour later, the test finished, and there were some minor signs of layer compression, which is normal for this class of printer, especially when printing directly on the build plate. More importantly, the test models were consistent across the surface, confirming that the build plate really was level. Now, with that out of the way, I went back to my usual approach and sliced the Artemis and Mahogany miniatures from DM Stash, which I use in every resin printer review. I ran them at 30 micron layer height using the default profile for the Uniformation HD gray resin. I supported the models, sliced them, and sent the job over. The exposure itself was solid right out of the gate, but I definitely overdid it on the supports. It took a couple attempts to dial that in. The second pass went too far in the other direction and resulted in a partial failure. By the third try, though, I had it right. The supports held firmly during the printing, but peeled off cleanly afterward with minimal surface damage. And that's always the goal when I'm setting up prints. Reliable supports without leaving behind multitudes of pit zits or hours of cleanup required. With both the 75mm and 32mm miniatures looking as good as I've seen from all other 16K printers, I moved on to the dimensional accuracy testing using my ultralight mouse body model. Like most consumer-focused MSLA printers, this is where limitations start to show. There were noticeable compression and stretching artifacts, especially towards the bottom of the print. Circular features like screw holes came out more oval than round, and measured dimensions were significantly off from the original CAD model. In the end, the top and bottom halves of the mouse didn't fit together properly. That behavior comes from a combination of factors: the physics of the print process, the exposure and lift settings, and the mechanical properties of the resin itself. You can see this more clearly with larger multi-part models. I printed a large multi-part Daredevil statue, and while the individual pieces looked great, sharp details, smooth surfaces, very little voxel stepping, assembly told a different story. Once the parts were brought together, there were visible gaps and misalignments. What's happening here is layer level warping as the print progresses. Each layer has to be peeled off the release film, and that peel step is the most stressful moment in the entire print cycle. The GK3 uses a straightforward lift and peel approach. There's no peel assist mechanism like the tilting vat on the Saturn IV Ultra, the pulsing release module on the Hager's Reflex RS, or the texture to release surface used by printers like the new Anycubic Photon P1 or the Formlabs Form 4. You can actually hear each layer tearing free from the FEP like a bed sheet ripping. With a rigid low flex resin like the Uniformation HD Basic, those repeated peel forces cause the freshly cured layers to warp slightly as they separate. Well, now we're just talking microns here, but over hundreds or thousands of layers, those small shifts accumulate. The result is a part that looks good, but is subtly misshapen, just enough to create fitment issues. Fixing that means epoxy sculpt filter, sanding, and extra work. There are two ways to compensate for this. First is through print settings. For the next multi-part statue, this time Supergirl, I adjusted the peel behavior. With brittle resins, warping isn't caused by weak adhesion, it's caused by stress being applied too quickly. Right after a layer cures, the resin is still warm and shrinking slightly. If the plate lifts immediately, that sudden peel creates a sharp stress spike that brittle resins can't really absorb. By adding a short pause before lifting and slowing just the initial portion of the peel, the layer has time to cool and relax. Separation happens more gradually instead of snapping free. With those changes in place, the Supergirl parts fit together much better. Some filling is still needed, but overall the alignment was noticeably improved. At that point though, I had reached the practical limits of what I could get out of the Uniformation resin, and I had used it up anyway, so I switched to a better material, a Hager's production resin. I ran a multi-exposure calibration first. Uniformation doesn't include a built-in exposure rangefinder in the firmware, but there is one on the USB drive. The problem is that it's pre-sliced. You can't adjust any parameters. It simply runs exposure times from 1.8 to 3.5 seconds, regardless of the resin you're using. It's fine for getting into the ballpark if you're completely starting from scratch, but real tuning still requires individual calibration models with your actual print settings. I ultimately landed on 1.7 second layer exposure and reused the same peel force reduction settings from before. This time I sliced a large multi-part Lady Deadpool statue and the results were dramatically better. Gaps were minimal to non-existent, parts aligned cleanly, and assembly was straightforward. To push things even further, I installed a brand new vat and filled the spare cartridge with Tech Blue Nylon Black. I normally reserve this resin for functional parts, but it was nearing expiration, and the next prints are for my granddaughter, so the extra toughness, well, it makes sense. One of the things I really appreciate about Tech is that they provide detailed slicer profiles for specific printers. I downloaded their chip-to-box profile for the GK3, imported it, sliced a Rumi statue using the default settings, and printed it. Those prints came out essentially flawless. Fine details were crisp, smooth surfaces were actually smooth, and there were no signs of warping. Every part fit together exactly as it should. Better resin paired with well-matched settings made a very clear difference. Now, there are still plenty of successful prints on the table that I'll get to, but before that, I need to talk about the problems I ran into with the Uniformation GK3T. The first issue showed up during the Daredevil statue print. Partway through the job, the printer experienced a hard crash. The print stopped, the touchscreen went black, and the system became completely unresponsive. At that point, the only option was to power cycle the machine. Since there's no power loss resume function, that immediately killed the print. The first time I got lucky, the failure happened near the end of the job and the print was salvageable. But a bug really isn't a bug unless it's repeatable, and this one definitely was. The same freeze happened a couple more times. In one case, it occurred right at the beginning of a print, which wasn't a big loss, but during this Zoe statue, the printer froze after several hours. The entire last inch or so of the torso never printed. Now, I was able to identify the exact layer where it stopped and sliced just the missing portion, and then glued the parts together, and that worked, but it's not something you should have to do. At that point, I had seen the same exact failure 3 times. That's a legitimate firmware issue. So I did what a normal customer should do. I emailed Uniformation's after sales support anonymously and explained the problem in detail and asked for help. About 12 hours later, I had a response. They sent me a new firmware build that they said would fix the issue, and they even offered to send a fresh bottle of resin to make up for the failed prints. That response was excellent, fast, direct, and genuinely helpful. What's frustrating is this could have been avoided entirely. There's an OTA firmware update function built into the printer's UI. I checked it during the initial setup and it reported that the printer was fully up to date. That turned out to not be true. The OTA feature simply isn't working on my unit anyway. And now, yes, I could have manually checked the support page. And yes, there was a newer firmware available there, newer than what my printer shipped with, but not the new one that they sent me. Anyway, since then, a newer version has been posted, but at this point, it's 2026. OTA updates are standard. I mean, even my smart light bulbs get firmware updates automatically. Anyway, I loaded the firmware Uniformation sent me onto a flash drive, plugged it in, powered on the printer, and it applied the updates automatically. After that, the freezes stopped for a while. I went through several resin changes and multiple large print projects without issues. Then eventually the printer froze up again. Thankfully, that one happened early into print and didn't waste much material. I emailed support again. This time the response took about 2 days. That delay turned out to be a good thing. They spent that time actively trying to reproduce the failure based on the information I provided. In the end, they were able to replicate it and identify the root cause, and it's a memory leak. If you run the GK3T continuously, job after job, without ever shutting it down, fragments accumulate in the memory. Eventually, the memory fills up and the system freezes. The current workaround is simple. Power the printer off after every few print jobs. For most users, this is a non-issue. If you print a few things, turn the machine off, and then come back later and print some more things, you'll probably never see this behavior. But if you're using the GK3 in a print farm style workflow or running it continuously the way I was, this can absolutely become a problem. Now, Uniformation is actively working on the firmware update to fix this. There's already a newer version posted on their support page. I'm not certain whether that one fully resolves the memory leak yet. I reached out to them again this morning while preparing to shoot this video, and once I get confirmation, I'll pin it in a comment below with the details. Now, outside of that, I only countered 2 other failures during testing, and both were support failures on pre-supported models. Every model I supported manually printed without issue. Since adopting the habit of periodically power cycling the printer, I haven't experienced any additional freezes, and I've put a lot more time on it since. All right, with that covered, let's look at the rest of the resins I ran on the GK3T and the results they produced. After installing a fresh vat, I poured in Soriatec Tenacious Clear. This time I skipped the automatic feed system and just filled the vat manually. The first print was a Christmas nativity decoration intended as a gift. The print itself came out perfectly, but I hadn't accounted for just how yellow Tenacious Clear actually is. I actually meant to order Obsidian Black and added the wrong one to my Amazon cart. I tried to make the best of it here, but that color wasn't what I had in mind. With that print technically successful, but not a great gift, I poured the remaining tenacious resin back out. The spout position on the vat is a little awkward, but it works well enough, I guess. I didn't bother chasing down the last few drops because I was switching to another transparent resin anyway. Next up was the Uniformation Transparent Red ABS-like resin. When switching from gray to black resin earlier, I used the built-in auto feed cleaning function, which does a decent job purging the line. A few drops always remain, but when you're going from one opaque resin to another, that dilution is insignificant. A couple drops of gray and 800 milliliters of black just disappears. Transparent resin is a different story. To avoid clouding the red, I filled a spare cartridge with isopropyl alcohol and ran a small amount through the feed line, then removed the bottle and purged the line again, catching all the purge material in a shop towel. After that, I loaded the transparent red and it came through perfectly clear. I printed a multi-part Phoenix model and a multi-part Bazog bust. Uniformation's ABS-like resin is a big step up from their basic gray. Using Uniformation's default profile for that resin, the parts printed cleanly and fit together extremely well. Once assembled, the seams were practically invisible. From there, I pulled the cartridge again, purged the line, drained the red resin, and switched to Sunlu Clear Blue. I printed the crystal components for the Supergirl statue base using the same exposure settings I had previously styled in for this resin on the GK2, and they worked flawlessly on the GK3 as well. I also ran a couple of miniatures with this resin and the detail came through perfectly. At that point, I removed the vat I had designated for transparent resins, clipped the gray vat back in, and reinstalled the cartridge that still had some Hagear's production resin left in it. I sliced a set of 32mm tabletop miniatures and printed an entire DM Stash campaign set, bases included, on a single build plate. Every one of them came out clean. Even at that scale, delicate features like bowstrings, arrows, and small jewelry survived both printing and support removal. Next, I loaded up some 40mm Sacred Knights. By the second plate, I was running low on the Hagear's resin, so I simply topped off the vat with some Soriatec Fast Gray and kept printing. The parts completed without any issues, no artifacts, no separation, no surprises. The biggest takeaway here is that the time spent dialing in resin and support settings up front paid off. Post-processing on the smaller scale miniatures was minimal. After support removal, washing, and curing, the final cleanup for all the D&D and Warhammer minis took about an hour total. And that's it. They were ready for priming and paint with very little extra work. And this is probably the biggest separator between the Uniformation GK3T and the other 10-inch class resin printers I've reviewed over the past year. At its core, this is a straightforward, no-nonsense workhorse that gives you enough control to dial in your exact preferences and achieve repeatable, predictable results. The Hategears Reflex RS Turbo is still the most usable MSLA printer I have in the shop. When it comes to ease of use, it's hard to beat. As long as the model is properly supported, the Reflex RS handles almost everything automatically and produces excellent results with basically no effort. The trade-off is cost and ecosystem lock-in. To guarantee those results, you're tied to Hategears resins, and the printer itself carries a higher price tag. The Elegoo Saturn IV Ultra 16K was a popular machine last year, and it can produce solid output, but it comes with compromises. The spring tension build plate introduces compression artifacts, especially in early layers, and those can't really be tuned out. The tilting vat does reduce peel forces and associated warping, but it doesn't eliminate them entirely. More importantly, it removes some of the control needed for fine tuning. That makes it best suited for supported single piece models like miniatures or small components rather than large multi-part assemblies. What puts the GK3T over the top for me is how well it balances capability, control, and day-to-day practicality. The inexpensive covered stackable resin vats make resin management far easier than most other printers. The mess-free build plate generally reduces cleanup time. Together, those two features alone change how comfortable it is to run long projects and swap out materials frequently. If you're looking for an all-around resin printer that can handle everything short of ultra-precise engineering tolerances, miniatures, statues, vehicles, props, decorative parts, the GK3T fits that role extremely well. It gives you enough control to dial in nearly any resin you want, a simplified workflow that doesn't fight you, and the ability to reduce resin mess and downtime using affordable spare components. Maintenance is about as simple as it gets. There's one lead screw and one linear rail to clean and relubricate occasionally. I crossed 300 hours of active print time before doing that for the first time. Consumable and wear items like the LCD, carbon filter, vats, and even the build plate are readily available, reasonably priced, and easy to replace when the time comes. In that sense, the GK3T feels like a proper successor to the GK2. Uniformation took the strongest parts of that design, the mess-free build plate, the latching vat, and the heated chamber, and refined them. The automatic resin feed system works well and isn't a nightmare to clean. The move to a 16K screen isn't transformative, mostly because current resins can't fully exploit that level of pixel density, but it's a noticeable step forward. And the tilting touchscreen is generally useful, especially in a workshop setup where printer height and access can vary. That said, there are still areas Uniformation could tighten up. A higher quality or better aligned Fresnel lens would help even out light distribution, and the stock PET screen protector really shouldn't be there. PET has no place on a UV exposed screen. Fixing those things alone would make a meaningful difference. And of course, the memory leak issue needs to be fully resolved, especially for anyone considering this printer for a print farm style use. As for which GK3 model to choose, I don't see a strong case for the GK3 Pro. The 385 nanometer light source is technically better for certain clear or engineering resins, but it doesn't bring enough additional professional features to justify the jump. Its best use case is likely as a dedicated low-cost unit in a small print farm focused on transparent parts. The GK3B with its ball screw falls into a similar category. Ball screws do have real advantage in some applications, but at the speed and precision ranges of a printer in this class, those benefits don't justify the roughly $100 premium in my view. Taking as a whole, the GK3T hits a very rare balance. It's flexible without being fragile, powerful without being locked down, and practical enough to live with day after day. For 2026, this is the resin printer everything else has to measure itself against. And that's where I land on it.